An example of vector subtraction is relative velocity. As a reminder, a vector is a quantity with magnitude and direction. For example, in the statement, a car is driving northeast at 80 kilometers per hour. The vector quantity is velocity with a magnitude of 80 kilometers per hour, and the direction is northeast. When trying to picture the addition of vectors, you should use the tail-to-head method. Draw each vector tail-to-head, one after the other, and when finished, draw the resultant vector from the tail of the first vector to the head of the last vector. When adding vectors mathematically, you will need to set up a coordinate system, calculate vector components relative to that coordinate system, add the vectors by component, before converting back to polar coordinates. Do not memorize the formulas. Rather, always check that the components are the sine or the cosine sides of the right triangle. Vector subtraction is similar to vector addition, except you are adding the negative or opposite direction of a vector. An application of vector subtraction is relative velocity. The phrase "with respect to" refers to the vector being subtracted. In this example, velocity of b with respect to a means the velocity vector of b minus the velocity vector of a. As mentioned before, this is equivalent to adding the negative of vector a to vector b. Note that this subtraction is the same no matter the position of the objects involved. Here is an example of a relative velocity calculation. We are given the headings of two ships, and we are to calculate their relative velocity. We start by reading the problem for information on the magnitudes and directions of the vectors. We highlight what is being asked for. Note that this problem gives us compass headings, which is a convention defining degrees clockwise from north. We draw the relevant vectors tail to head with our anticipated resultant vector and set up the coordinate system. We calculate the vector components. Pay careful attention to SOHCAHTOA, as in this coordinate system, the x components are the sine components and the y components are the cosine components. We add the vectors by component paying attention to the signs as we calculated in the previous step. Before converting back to polar coordinates for the resultant vector. Reread the problem and check that the solution makes sense by looking back at your picture.